what is that? This one is there. Purchase order manual is there. This is nothing but to study different types of sensors used in the industry. Industrial strainer kit it is for measurement of different parameters. It is given details. Here, briefly, I will tell you what are the you need to measurement here as per your purchase order. You need to study the pressure. You need to study the temperature. In the temperature, there are different types of sensors are there. What are the different types of sensors you need to study that is given in the purchase order? Accordingly, we have made it. So, what is the different pressure you are using? That is also given. Pressure, temperature, level. These are the three parameters. The purchase order is there. Apart from that, flow is there. So many things are there. But this purchase order is restricted to only three types of sensors. One is pressure, one is level, one is temperature. For pressure, they have given 4 to 20. Any sensor, how you are measuring? Example pressure is coming. Digitally it is showing the pressure. Gauge you can read directly. Pressure is going digitally showing 1 bar, 2 bar, like that you can read it. But in digital system, how you are reading? So any sensor, once you press it, because of the electromagnetic induction, it produces some voltage or some current output. The sensors are different types of sensors. One sensor is current output is there, one sensor is voltage output is there. Any sensor, you take temperature, flow, then pressure, level. It produces only two outputs. One is voltage output or current output. That you should keep in mind. Any sensor, level you measuring it, the output is coming here. For example, petrol bunk person is telling 2 liter petrol is there. You just read the petrol 2 liter, you run your bike and go. Whether 2 liter is coming or not, you are not sure. They may deceive you. How it works? The output from the sensor, particular milliamps gives 1 liter petrol. So much of milliamps is coming, 1 liter petrol, they will calibrate the meter. That helps in calibration of electronic indicator. Any instrument, basic instrument you need not have to calibrate, like volume of the tank, no need to calibrate. You know the width and length, fill the water, this is the water quantity we are filling in the tank. So much of so many liters, 5 liters, 6 liters, you will get no. It doesn't require any calibration because it is a physically fixed parameter. Geometry is fixed here. They are not changing. The instrument is not like that. It has got certain electronic components, certain sensor output is coming, registers are there, so many things are there. There will be some losses will be there. Because of the loss, the meter bounds to give some error. So that error needs to be nullified and set it according to the basic system. So whatever the pressure is coming out from the sensor, output from the sensor is in milliamp. For example, here you are using as per purchase order, this is giving 4 to 20 milliamps output in the, you can see industrial pressure sensor, the 4 to 20 milliamps output is there. You have to study the 4 to 20 milliamps output. Yeah, pressure measurement, captive measurement, this pressure, this 4 to 20 milliamps output. These two, both pressure and captive, this is the level measurement, this is the captive sensor. This is the rod is there. It is the capacitance sensor. This is 4 to 20 pressure sensor. This is the pressure sensor, this is the level measurement sensor. Both produces 4 to 20 milliamps output only. Here the scaling is different. You are reading pressure, what is the unit of pressure?
4 to 20 milliamps minimum.
No, that is the standard range for the pressure. At zero
4
pressure,
means 4 watt?
4 milliamps, current it will come. At zero pressure, it produces always 4 milliamps. When you give an excitation voltage to this current, from the electronic device, some voltage will be given to this. It gets excited, the coil. It starts producing 4 milliamps per turn because the pressure is zero here. At 4 milliamps, you need to read, that is how you need to learn the scaling of this. We call it as a scaling. Scaling means according to the unit. Pressure unit is, what is pressure unit? Kg per centimeter square. 4 milliamps, 0 kg per centimeter square you are supposed to read here. At 4 milliamps, when there is no pressure, pressure gauge is 0.
4 is the minimum.
4.8949. It depends on the manufacturer. Maximum you are asked is 4, maximum is 20. That's all. It depends on the supplier manufacturer. Even at 20 milliamps, this is the 10 bar sensor actually. But we are measuring here up to 2 to 3 bar. Even 40 bar sensor also 20 milliamps only. Manufacturer standards are like that. At 40, same pressure sensor at 4 bar you will get 20 milliamps. At 40 bar also you will get 20 milliamps. But that time you need to do the scaling. 20 milliamps, if the sensor capacity is 10 bar you need to fix it. Zero is common. Zero display is coming. That means no pressure, zero is coming. That means the current will be around 3.89 to 4, it will come 0.01 error will be there in the meter. That is acceptable. That you need to set it. Here the basic technique is what is the student has to learn here, how to do the scaling, what is current, how much current, what pressure we are getting, that how to do the setting here. That they need to understand. 4 milliamps we are getting, 4 means 3.89 or 3.9 somewhere in that range will be there, zero pressure will come. Since the pressure gauge capacity we are going up to 10 bar here, but reading capacity will be maximum 3 to 4 bar, safety point of view. So 3 to 4 bar, what is the current output will coming, it will read here. At 10 bar we are setting 20 milliamps. 4 milliamps to 20 milliamps range the gauge has to operate. That is for the pressure. Got it? Similarly, here the scaling you are not reading kg per centimeter. Level how you are measuring? In terms of meters, millimeters, level of this tank 100 millimeter, 200 millimeter, like that you are putting the water. So that millimeter you are using. So for 0 level, that means 0 centimeter, 0 meter, you are getting 3.89. Again the current output will be there. It will be going to the meter, it will read as a 0. Maximum is 460 and 465 is there. Up to hole we are taking it. This is the capacitance type sensor. From this to this, it is 465 mm. We have given the size. So when the water gets filled, the meter has to read 465 at 20 milliamp. The current will be 20 milliamp. Both you can read in this. Current also you can see also. That can be done in this. So function of this is normally what will happen, no? Suppose you want to set the level around 100 or 100 or 200. Up to 200 it should work. Once it reaches 200, the pump has to stop. Once it reaches come below, pump has to get off. Then again, below 200, whatever your set point is there, below 200, pump will get on automatically. Keeps on off and down, off and down. At one point, the graph will go and straight, up and down, it will become straight till it stabilizes. To that level, the pump keep on off and on. That operation you can study in this. So this is called industrial automation. Automatically you are maintaining the level. Suppose in milk dairy industries, their milk is pouring. The operator need to maintain, he will give in computer. These things are actually connected to the computer normally. Since it's the basic instrument, we show manually here. So if you set for 200, operator set milk level 200. Anytime, not necessarily this much of tank. Big tank only same capacity can be. There also again 20 milliamps only. So 200, 100, whatever you set it. Once the milk level reaches 200, the pump will automatically stop. Operator will not have to go and switch off. What will happen if you forget it, milk will overflow, some problem will come. Automation industry nowadays, more or less, automatically it should operate. Once the milk or whatever oil level comes below 200, it will pump. It gives the signal from this PID controller.
Packaging.
Automatically packaging. All those things happen. When is the bottling unit automatically. At particular level, it will cut off the fluid. And once the bottle comes, it will again put the fluid in that. Like that. Different. They're all controlled by these PID controllers. This is called periodic. P means proportionate, I means integral, D means derivative. When you are studying in engineering, these parameters will come. Integration, control system. Integral timing, derivative timing, you need to set it. Accordingly, the gap up and down, overshooting and undershooting. Because sometimes if you are setting 200 or 190, it will go up to 200, 220. Suddenly 198 will never cut off. There will be overshooting and undershooting will be there. Initially, because of the trial. So that you need to study. We are not giving you exactly 200, it should cut off. 210, 20, how it will go. Then 190, how it will come. You need to study off and down operations. That is your job for that reason. Because it is not exactly 200, you should cut off, and below 1 mm below it should on, it will not like that. We are not operating with that. We need to study how it behaves. What is overshooting? What is undershooting? All those things it will come in when you study the automation in the industry. What do you mean by overshooting? What do you mean by that? All these things you can study. This is regarding about the pressure and temperature. They are all related to 4 to 20 milliamp. When you go for here, one more thing we have written is temperature is also there. You need to study 3 types of temperatures are there. One is K type, other one is RTT, the other one is thermistor. Thermocouple is K type, RTD PT100, thermistor. Then you put the switch number 1, thermocouple, number 2, RTD PT100, number 3. Only 3 are there, 3 we have.
4, 5, 6, 7 are?
It's not connected. They are not connected. You go for some other PT100, so many thermocouples are there. Only for your trainer kit, it is only 3 is there in the syllabus. Accordingly, you can study. Here again, the output from the sensor is voltage here, not current. Different sensors have got different voltage. Only 2 output will come. One is current, other one is voltage always. The sensor, any temperature sensor, there the temperature, how it works. You are reading the indicators, no? Thermocouple, all those things. Here you can study how it works. The voltage, it produces some voltage. Any 2 biomaterial, if you make a junction, it has got a 2 biomaterial. K-type sensor, what is it? FTK sensor, Ferrous constant, and we call it as. This is called RTD, resistant detective transducer. RTD it is called as. It has got the biomaterial. When 2 biomaterials made a junction, it produces some millivolts. When you put in the cold or hot junction, it produces some millivolts. That millivolts is converted to degree centigrade. There also it will be like that also. See, for K-type, we have got the thermocouple chart there, millivolt versus standard chart is there, standard manufacturer chart. For 1 millivolt, so many degree it should read. For 2 millivolts, so many degree it will read. In RTD also it will be like that. In thermistor also it will be like that. Particular millivolts only it will read. Accordingly, the temperature will be set. That is regarding of the 3 thermocouples, pressure and captive resistance. One more is there, strain measurement. Here, this is the strain measuring system. This is one more sensor. Once you put certain weight, the material is subjected to the eccentric load. If you press or something, you put the weight, subjected to the strain. Once you strain, that output from the strain, it will be in again millivolts. That millivolts will be read in the separate indicator. These are all 3 are common indicator. For strain measurement, it is different indicator.
Capacitive is also there, sir, actually.
Capacitance is there. This is a glass tube. Whatever inside rod is there, no? That is a capacitance. For that drawing is there, I will show you the drawing also. How
we
inside,
measure
how inside
capacity.
construction, everything is. See, there, once any fluid or any material, even solid material, some comes in contact with that, when it presses and it moves up and down, there will be some voltage, due to the electromagnetic induction, some voltage will be developed. That voltage will be taken into this wire and connected to the meter. That voltage is measured. Actually, it is coming here millivolts only. But you are reading because of the scaling, like that 2 liter, 3 liter, you are reading in the petrol bunk, no? Your petrol. It will be like that. Scaling will be done in the meter. It is called as scaling. As per your convenient. Common, both are common. Both will produce same photo. Sir, both is producing same. How you are reading 2 here, how you can ask the question. Here it is in millimeter, it is in kg. It is your scaling. You are convenient. You give, for example, you don't want to draw a particular graph. You do the scaling, kabaddi ground or cricket ground. You cannot make big sheet and you do it. To reduce it, to make your size, you do the scaling. Like that, it is a scaling system. To read the output, you do the scaling. Petrol bunk, they do in liters of volume. Liters, they will write it straightly. But here, actually, liters, everything, anybody can study, any layman can do. But engineering, technical people, they have to study how it is working. What is the output coming from this? That they need to study. No? So, that is what I am telling you. They are all 4 to 20 milliamps output. That is why it is called as a industrial sensor kit. There are other so many sensors are there, like flow sensor is there, velocity sensor, RPM is there, measurement. They produce pulse. Again, the output will be voltage.
Different types of sensor.
Industrial sensor kit. It is called as industrial sensor trainer. Pressure, level, and temperature. We have given 3 sets. In temperature, 3 different are there. In pressure, 1 type of sensor is there. In level also, another 2-3 different types of sensors are there. But pressure will be limited to only 1 type. Active resistance. Most of the things they will study.
Capacitors are there?
No capacitors.
Level.
No.
Level measurement is
No capacitors. Inside there will be a, here this is this capacity.
Level measurement, no?
This is the level measurement.
What is sensor?
Inside that rod is there, no? That captive resistance sensor. Whatever there is, when the liquid moves, There will be a electromagnetic induction inside.
Dielectric changing.
Dielectric changing. That output will be in terms of 420 milliamps current.
Only capacity type.
Capacity type. 420 milliamps current. It's a dielectric current, nothing but. Here the strain gauges are there inside. When the pressure, apply the pressure, it produces again output 420 milliamps. This is the pressure sensor.
Pressure sensor.
Yeah. Earlier diaphragm types were there. When the diaphragm moves and up and down, the electromagnetic induction will be there. For that output were. Nowadays, these are all strain gauge based sensors.
This is heater, huh?
This is heater. So because you need to measure the temperature at different temperatures, no? We have to produce the source, heating source we need to give. No? Unless you don't give the heating source, you only room temperature you can do it.
Direct 230, huh?
No direct to we are controlling the regulator. How much heat you want, you can put the regulate it, give the heater, temperature you can make it. Just to read different temperature, we have made one source, heat source. Because in industry, all those things, we cannot bring those furnace, all those things. Student has to study the concept.
Very high temperature.
No.
I have all the things here.
Even 1200 degree we give, small furnace we are giving.
Instrument lab.
Okay, sir.
We have all.
It's already
It is
there.
already available, sir. Only thing is, it is a portable. Portable.
You can study the actual working here completely. Shall we start? I will explain about the meter. Once you start this meter, you want to measure the temperature. We have provided the switch because it's a mini kit. Now everything has to be controlled in one panel only. So one switch is there, pressure measurement you have to keep. If you bring it center, nothing will be read. It's a zero. If you bring it below, this will be level measurement. The level measurement will be done here. If you keep it to the center, no reading, no measurement you are doing. When you are reading temperature only, you have to keep it to the center. Otherwise, either level or pressure, you can read it. So once you put it at the pressure, now what is the pressure? Somewhere around 1.0 something is there, it is reading now. So how it is reading, I will show you. PIDs have got the different programming system. Only level 0 is related to you. Level 3, level 1, level 3, level 4, all those things, automation, all those things are there. One PID control entire instrument equipment in the industry. So for that reason, these two are the up and down. How to go enter in the level? You have to just light press it. It will show level 0. Once you come to the level 0, it will hold for 30 minutes. If you don't program within 30 minutes, again it will back to the square one. So what you have to do? Now input you have to give. So what is the input? 20 milliamps we are giving the input because our input is 20 milliamps here. Because we are measuring level and captive. So input is 20 you have to give compulsory. Program. Then next is resolution. How much resolution you want? 4.00 milliamps you are reading. 20.00 milliamps you are reading. Resolution is 0.01 you have to set. RESL is resolution. Then go for next. Display scaling. What reading you have to read in the display? You want to read from 0 to 10 bar or 2 bar, 4 bar or 460 mm. Display scaling initially should be low. Display scaling low it is. 0 it should. At 0 pressure it should read 0. Then display scaling low it should be at 0 pressure. What is the current output should come? 3.89 to 4 milliamps.
4 milliamps.
That you have to set it. Then go for next. Display scaling high. What is the maximum high? Display scaling 10 bar we are reading. Because the pressure capacity, sensor capacity is 10 bar. So that is high. Then you go for display scaling low. What is the current of display high? Input scaling high. What is the input scaling? You have to give 20 milliamps at 10 bar. This you have to program it. Once you program it, this job is over to measure this one. Resolution, reverse scaling, it's not required for you. These are all not required for you. Then it will come to level 0. To come out from the level 0, you just hold these two. It will come from the 0. So now it is reading pressure value. So I will show you, make it 0.
Only measurement.
It's only measurement. You can do the controlling in this also. Pump on and off, everything. In pressure we are given the measurement system. In pump system, level control also you can do. How it is overshooting and undershooting with the help of PID. I will show you that step also. This is about the pressure. You press it,
level only connected.
a level is connected to the pump, auto.
Only controller working.
Controller is working, levels. You can put the pressure, whatever pressure you want, you can keep on reading. Somebody has to press it, so you cannot. Up to 2 or 4 bar, you close the valve. Before any raising the pressure, you close the valve.
Or use our compressor.
Your compressor can be also used. Small compressor is there. Big compressor is not required, only small.
2 bar, I think. You do that.
पेन అయితే సచ్ అయ్యి
Make it whatever you want.
ఇందాక
To
నేను
make it.
చేసి-
That will
hand
be
pain అయితే-
indication will be done.
ఇందాక 2 వరకు ఇచ్చాను నేను
రికార్డ్ చేసింది దాంట్లో
పైప్ లేదు సార్ కింది వరకు కింది వరకు పైప్ లేదు
You want to keep it for 1.5? You can slowly release, keep it for 1.5. It will read 1.5. Anything, if you want to make it at you can connect to the compressor. Once the value is, this has got the 2 parameters, set value and process value. The process value will be always indicating what is the present pressure. Set value, you need to cut it off for 2 bar only, you don't want to raise. So you have to set it for 2 bar, whatever it is, you just hold it. You can reduce it, increase it, whatever the setting value you want to make it. I will show you in the level also.
maximum how much, sir? 10?
No, 10 it cannot take, maximum 4 to 6, 4 to small tank. Up to 4, 5 bar you can go. In your big compressor is there, it will go up to 12. 10, 12 you can go. But you should not fill in this. This capacity is limited
Only
to
4 bar.
Because it's a small industrial train. That's all. Actually, nothing is mentioned in your order, just we are given one tank, everything. Because we need to give source, no? Pressure to raise the pressure. Simply, it is only 420 milliamp sensor is mentioned. Simply, I give this sensor, you will not be understanding how it is working, what is the output. So, we have made a system so that you should understand the concept, all those things. There we are given the source, pressure source, all those. This is about the pressure. Now, we go for the level. You can release this, make it 0. Then again you need to do the scaling. Before doing the scaling, you need to put this at the level. Level measurement, pressure measurement, one is there. Now it is switching on this. So you need to do the scaling now. You have to go for the input again, level 0. This is where you need to get the knowledge about this, how to do the scaling, all those things. Students should learn. No? Then what is input here?
20 amps.
20 milliamps is coming. So you need not have to change. Input the resolution is, we need resolution 1 because 1 mm we are reading. So 0.01 is not required. 1. Then what is the display scaling? 0. From the 0 you need to do. Display scaling low. Lowest is the value of the display scaling 0. Then go for 3.81. Input to the display scaling at 0, how much input should be there? 3.89 or 4 milliamps current should be there. That you have to do the programming. These are the programming. Then input scale high. High ours is 0 it is giving, but our restriction is 460. From volt to volt it is 460, we have to set it for 460. For changing any digits, no, you need to press this tick key. 460 you have to bring it below. Keep on changing one by one.
Minimum, sir?
Minimum is 0, maximum is
0,
460. 460 or 65.
0 అది ఇన్పుట్ కరెంట్ మ్యాక్సిమం 4 మిల్లీ యాంపియర్స్ కరెంట్ అది 420 కదా 4 to 20 మిల్లీ యాంపియర్స్
So for 20 milliamp, 465 we have set. Then reverse scaling is, this is called reverse scaling low, not required. Level 0, then you come out. This programming manual is there, I will give you also. Say, the concept is, why this has to be selected. See, this is only 400 meter tank. Sometimes your tank will be around 30 meter height. For the 30 meter, you need not have to go for that much of big these things. In the scaling itself only, you can increase or decrease the value. 20 milliamps is same. It won't change. You go for a 30 meter head tank or 2 meter head tank or 1 meter head tank, cutoff is 20 milliamps. The manufacturer's output current from the sensor. You need to study what is the maximum output.
It is
from the
suitable for
sensor
small scale
according to
industries.
any big industry.
Big industry also for 20 milliamp.
Yeah. They will use for 20 milliamps. So the maximum industry, most of the instruments comes with the 20 milliamps.
20 milliamps.
Very rare cases they go for a higher milliamp. So normally nobody will prefer current is there. No, should not go even 1 amps also it will give you shock.
OCL, HPCL plants are
Everywhere,
there.
sensors are
using
more or less 20 milliamps
Universal.
output only. Universal.
Throughout the world,
Yeah,
see
accepted
the
that.
signal used as standard.
Standard, because your PCB has to process it. It has to withstand that current. Higher current, your chips, all those things cannot withstand. It will burn away. For that reason only, for the signal processing, the output from the sensor is cut off that. It is taken into all these circuit board account, everything, chip account, chip capacity, all those things they have designed for. It is in milliamp, not amps. I'm talking. See what will happen now when it is mentioning example. I will tell you. Here you can see. Level 0, the programming will be done. Input is there. No, you need to program it for input current. What is the maximum input current that you need to program? Then next is resolution. How much resolution you want? Normally in level 1 mm we check it. We do nobody check it. Then display scaling. What you want to read, that you have to give display scaling. It is called. For input scaling and display scaling, you need to program. Display scaling. One resolution 0 from 0. If you are starting from 100, you can program it for 100, it will read from 100. As per your convenience, you can program it. Then input scaling low. What is the low current required for in 0? It is 4 milliamps, 3.89 to 4 milliamps it will come from the sensor. Display scaling high. What is the maximum value you want to read? Suppose you want to read 2000 meters, that you can program it. Display scaling high, it is. Input scaling high, what is the current you required? And you have to give the input to the meter, no?
Yeah, scale
20 you are getting.
can
That is there. Really, everyone is 100, 100.
Up to here 100, sir. This
Up to there,
this is 200.
yeah.
400.
465.
Let us provide on scale.
Scale, what will happen, no, sir? If I provide, because of the glass outside will be there, no? The level will not match.
will kill.
Where you are? Here.
Side.
You may not coincide exactly that line because the gap will be there, no? Glass.
స్వీట్ షాప్ ఆపోజిట్ రెండు అపార్ట్మెంట్లు ఉంటాయి రైట్ సైడ్ ఉంటుంది
Now, shall we start?
బిఫోర్ దట్ యూ హ్యావ్ ఎనీ డౌట్స్ ఏమైనా ఉన్నాయి కాంపౌండ్ అండ్ డిస్క్రిప్షన్
हम कनेक्शन किए क्या? हम पार नहीं हो रहे.
వన్ సార్ ఇట్ ఈస్ ఆన్
Closed.
It's directly going up. This is green wall.
ఓకే
Okay, the tree.
Motor is on now.
Motor is on. It's working.
Air gap. Air gap.
इसको खोल के देखो. Can go up to 200 now. Now set value is full. We can reduce the set value later on. First I will do one thing. I'll put off the pump at this set value. So I'll set this value around 150 or 200 something. Now what is the second one is 200. Now I'll set it for 200. Now pump is off. Now pump is off. Unless you bring down the set value, pump will never get on. So what is the set value 200? It is 280 it is reading. Slowly you keep on reducing. Once it comes below this 200, the pump will get on automatically.
Which is PID on off?
No, it will off. PID on. PID. It has got the proportion, integration, derivative timing also. For that you need the software to program those integral time. Now it has gone. Again it will come down. It is called undershooting. If it comes below 200, it is called a certain particular undershooting it will done, then it will go overshooting, undershooting. It will set at particular point after some time. The graph will go up, down and it will become straight. When you see in the software, you can see the graph also. Now you see 191 off. Now it is getting
Now
on.
it is working in on off.
On off. It's only on off, not regulation system. Regulation system is different again. For that reason, you have to make the programming and use the regulating valve for that. Pneumatic operated control valve will be there. Those things has to be used. Whatever the water is required, that much only it will feed. Now you see, if it comes below, automatically gets on. $11 mm is overshooting. 6 mm is undershooting. 196 or somewhere around 190 it is on. It is undershooting. Overshooting, undershooting, it keeps on making level certain interval of time depending on the PB setting. PB value is called proportion band is there. There got the integral DT value, set 1, set 3, in that it will come. That has to be operated through software. In Bhimavaram we are given that same system. You can compute it through operator. T value you can set, DT value. So that this undershooting will reduce, overshooting will come down. 200 will be there, 200, 2, 3, like that it will operate. Then it exactly 200 it will set after switch on. Depends on, because they need to disturb it and they have to learn it. If you disturb derivative time, what will happen undershooting? Because you are not running industry to make it exactly and run and watch it. You need to learn. If you do the derivative time, reduce it, what will happen? If you increase the derivative time, what will happen? All those things they should get the training. Then only they will be operate. Some fault is coming, they can study what is wrong with the meter. They can easily sort out the problem. These students has to tomorrow they have to run that automation industry. They need to study the fault diagnosis also. Do the fault diagnosis also.
No, PT100 also there, huh?
PT100 is there, sir.
PT100.
PT100 is this one. This is K type.
K-type.
This is thermistor is tidy.
Three sensor temperature only.
3 sensors. It is written only 3 for us.
Selection.
So this one is K selection.
This is K, sir. K. Yellow type is K. This is RTD or PT100. And this is thermistor.
Selection is.
Here, 1, 2, 3. 1 is this one, 2 is this one, 3 is this one. Switch is
Oh,
there.
switch only.
Yeah.
T1, T2, T3.
Okay.
If you set for 250, the 300 I set it. Set value you have to increase. Once it goes to 300, automatically it gets cut off. 300 overshooting or undershooting, same process will be there. Exactly 300. It will come down now. Again it will down. That's how the concept is to show how the automation industries are working, how the filling will be cut
So
off.
what is
how
this
the
one, sir?
packing will be
This is
done.
strain value?
Next time. Let me not confuse it with you. Everything will be clear to you. Any doubt is there, you can ask me. One by one I will finish it. So that next is only temperature is there.
Temperature.
All the three you can study. Strain is only 5 minutes job. That you have to put the weight, certain strain output will come, that is measured directly there.
Showing out 2 means out 3.
That means relay is cut off. Is already out.
Out 1?
On it is now. When cut off is there, the out will come. That cut off is there, out will come.
On off indication.
It's on off indicator.
ठीक है अच्छा है
బాగుందా సార్?
మీకు అండర్స్టాండింగ్
Because what will happen, no, I will not exactly reading actually.
ఆపేయాలి చూసి.
Now we go for the temperature.
After that staying sir.
For temperature setting, again you need to go for level 0. Just a hand touch, don't press it more, not required. Once you go for the 0, press what is input you record, input is 20 milliamp. Now input we have to change. We have to give in millivolts, voltage. K-type, no? The first is K-type. Now we have to put it out. The level has come down. Resolution 1. This we have to change now. Milliamps into voltage we have to make it K-type it is now. The sensor is K-type we are studying now. First we go for the K. L it is. It is A. This is R. E. C. S. R. E. T. T-type. T-type thermocouples are there. This is K-type. So one, this is K-type is over. What is the resolution you want? Compensation? Yes. What is the resolution you want to read? 1 degree. Degree. What is the unit you want? Degree centigrade. High scale reading maximum 1300 not required for this. We are not reading any 1300. Only 100, 200 you can make. Let it be as usual. Minus 200 you can go also. Level 0. Then you can come. What is the present temperature? It is reading now. K-type it is 30 degree is there. It is reading now. It should be in the center. When these two are not using, when temperature using, the switch should be in the center. That you should remember. Okay. Now we are heating this. You heat the regulator. Keep it for around 25% something. It is like a fan regulator only. Wait for some few seconds. The temperature will start rising once you start heating. Here certain millivolts is generated. That millivolts certain maybe around 0.1 or 1.2 something millivolt. That is equivalent to 33 degree. K-type temperature, you have the millivolts versus temperature chart. Sir, I think you must be knowing that. Temperature versus millivolts are readily available. For particular temperature, what is the millivolt you can see. With the multimeter also you can check it up. In Google also you will get it. I will show you the chart also. I have the chart. You can give it. So now it is raising, it is heating. Now it is raising temperature. Like that, 3 different you can study. Now we are studying with K. Go up to 50, 40, 60 degree, whatever you want. Accordingly, what is the millivoltage is coming, that has to be read. The basic concept here is study the sensor character and sensor type of sensors. What is the characteristic? Different sensors. Drawing I will give you. Junction box, section. I have the drawing of these sensors, everything. How it is junction is made. Everything you can study, even pressure sensor drawing is there. This drawing is there, I can show you. You can show you inside construction. Because basic concept is to study the different types of sensor. The student has to study that concept. Because in industry they goes, when something is working, on what principle is working, what is the type of sensor, they should understand, no? The basic if they study it, they will be thorough in that. Exactly this may not be there, but the basic system will be the same there. Most sophisticated one they will use it, but the basic is capacitance only. Dielectric current is coming, that is measured. So once they get the basic thing, they can study.
Backside you given these points, no?
Points are there.
Points you can measure resistance.
You can measure voltage also in the points.
RTD resistance you can measure.
RTD you can measure resistance. In thermocouple you can measure voltage also.
Millivolt coming.
Millivolts, both you can measure.
On condition you apply a multimeter, you will get a
Mark condition, you touch the thermocouple points, you will get the voltage, whatever, directly.
Mr. is only.
That is only. See, it has gone. Don't go for higher. Don't will get burned. Even in some college we are given 1200 degree also. For it we are considering furnace.
బయటకు
Possible. To the relay only you can cut off it, but what will happen? No, already it is heated. Actually, heated temperature will be more than the thermocouple change in temperature. So unless that temperature and the chamber temperature become equalized, it will keep on raising even though heat supply is cut off. One college this question has come. One professor, he started arguing with me. Then I asked him, what is the equipment first you tell me, how you bought it? No, I need to study the temperature. Why you are worried about the cut-off all those things? You are not getting any automation system.
It will go above.
No, that was working, sir. That was working. The idea was not like that. His idea was different. It should cut off exactly set temperature he is telling. That's what he is not able to understand that. I told him, your sensor is in the chamber. Heater coil is there. Once it cuts off also, heater coil will be red. It keeps on slowly cooling down. That unless the chamber temperature and heater coil temperature gets equal, it will not cut off. Temperature went on rising. Because he said, no, you are setting 200, it is 250, it is going. I said, whether it is cutting off or not, you see. It is off already. That you have to see. 200 means once the temperature is 200, chamber temperature, coil temperature, there are two are there. One is coil temperature, other temperature. Coil temperature, coil will cut off. It takes time to equalize the temperature to coil temperature. That is why it is overshooting much. Like that 2-3 mm it is overshooting. Then it will overshoot more because the coil temperature is higher than the chamber temperature. The sensor is fixed in the chamber. Then he got the idea. Because of it, still it will be red. When slowly it will become off. Unless the surrounding temperature and coil temperature equal, your indicator will not show exact temperature what it is reading.
వినకపోతే బయటికి వెళ్ళిపోండి డిస్కస్ చేయొద్దు అక్కడ.
Now we go for the bit for whether you keep it or you will later on also you keep it, but you do the scaling first. Go to the L0.
మళ్ళీ అది జీరో చేసి మళ్ళీ PT 100
Resolution 1 degree only. Degree centigrade you need to read. If you want to read degree Fahrenheit, it can be done by changing this one. Normally we read in SI unit. PT 100 will be maximum. Scaling will be around 200 degree. 100 degree normally we do. You can bring it down to 100 degree also. Say around 200 degree we will keep it. It doesn't matter what degree you keep it. Only it goes up to that, within that limit it will operate, that's all. Whatever the limit you put, within that limit it will operate.
No problem, 700.
Then level 0. Program will come out. Now we are keeping it for T2. This you have to change PT 100. That I not say. K it is only showing. K is there, no? Then you have to input. You have to change as PT 100 now. This is PT 100. Now resolution 1 degree centigrade, 850 high scale. Those scaling is 100 minus 0. Now it will read. Okay. That time it was not reading. It was reading only room temperature because we have not done the scaling. Input you need to select. Most of the industry what they will do according to the sensor they will put in PID all those
Setting
things.
process of written.
No, I will give the company manual only. You get everything. No, company manual detail is there. Connection drawing is there. Everything I will share you right now. I have company manual. In that everything meter drawing is there. Programming system is there. What is L1, L2, everything is written. Very neat it is. You got it now? This is about the PT 100 sensor. Now go for the thermistor. Thermistor again it is in millivolts. Voltage you have to go. You have to compare input, you have to change, no? Now we are reading wrong because our programming is not correct. That's why it is not reading properly. Level 0.
It is in PT 100, sir.
That doesn't matter. Switch doesn't matter now. We have to program it first. 10 millivolts is our maximum. Input scaling. Resolution 0.4 because the calculation is for thermistor is 0.4 we have made. 0.4. That's the constant for thermistor constant we have, standard constant we have made that. Display scaling low, 0.4 no?
Display scaling.
Low, 0.
Scaling. Display should show 0.
0. Then input scaling low,
Input scaling should be 0.4. 0.40.
0.40 na?
Yeah. Then display scaling high is 100.
1 second. 0.40.
0.4.
Okay, display scaling high, 100 ah?
100.0.
100.00.
100.0.
100.0.
Yeah.
Okay. Input scaling high,
1.35.
1.35 na? మీరిద్దరు చూసుకోవాలి మొత్తం ఇక్కడంటే తుప్పు పట్టింది చెత్త పట్టింది అందుకే పద్ధతి తెప్పించాడు ఇప్పుడు మార్నింగ్ రాగానే 10 o'clock డెమో స్టార్ట్ చేయాలి ఇద్దరు వాళ్ళకి
If you go to span, it will become 0 also.
జస్ట్ తీసుకోవాలి మీకు వాళ్ళకి అది వెళ్ళిపోతుంది ఫైవ్ సెల్ఫీలు ఉంటాయి కదా అది పెట్టి స్టిక్ తెచ్చుకొని మీరే ఇచ్చుకోండి డెమో మీరు టైపులు పోతున్నారు Okay, 1.35. Then resolution, reverse scaling, no? SPHL, that is not matter, no? Okay. But it's showing 28.12.
कॉल कर
Hello?
कट कर जैसे
Okay, let it heat. In the meantime, I'll show this strain. Initially, this is also works on the same principle. It has got the strain gauges inside. Huh?
సార్ చెప్పి స్ట్రెయిన్ గురించి చెప్తున్నారండి.
Uh-huh. इधर स्केलिंग करा लेते हैं. But it is reading, it is not reading. 115 it is reading. It's high actually. Yeah.
No, wiring you check. Maybe wiring is not.
No, it was done the same similar. We have not removed any wiring. We have done it there only. It was reading properly there.
The settings are correct only no. Check
I'll
the
tell
setting
you.
once again.
That time I made the setting 1.35 something. Input,
Correct, 1 point.
input is AU. Resolution is 0.1. Resolution scaling. Display scaling 0 is there. Then input scaling low. 5 is there. That's 5. Display scaling low. How much it has to be?
Display scaling low is 0, no?
0. That's it. Display scaling low is 0.
No.
But input scaling low.
No.
5 is there. 5.00 is there.
No, it should be 0.40.
0.4.
0.40.
0.40. Oh, it has gone to -5 actually. Ah, 0.40. Display scaling high 100. 100.0.
100.0.
Input scaling high 56.00 is there.
No, it should be 1.35.
1.3,
1.35.
0.4 every 10 degree 1 millivolt.
No, every 20 milliwatts is
20 millivolts 1 degree.
19.5 milliwatts.
But I set it wide as well. Reverse scaling nil, no? Especially. Now it is showing 1 again. Hello? It is showing 1.
3 पे है.
3 पे है ना? हाँ.
Check this entries.
हाँ.
Entries you check again.
That is out it is showing actually. It is that our indication is there, no? Out 3. Ah, that is come out, I think. But heat is there. Because other reading we are telling, other reading they are coming correct. See, AU is the input, no? AU is input correct, no?
10 volt.
10 volt, I input.
10 V.
Correct, 10 volt. Then 0.1 resolution. Display scaling 0, low. Input scaling low. 0.4, no? That is 0.40. No, that input I made it wrong actually.
10 volts.
Then display scaling high 100.00. Input scaling high 10.00. That is 1.35. That is changing. No, initially input I made it wrong, I think. AU mode only I kept. Actually, I did not make 10U.
10 voltage.
10U I did not give. That's why reason. Everything was changing. This one only I did not practice on that day. I did 2-3 times, but after that we have dispatched this. Other things are working. Okay, there is reverse scaling, that is okay. No, it's okay. It is reading now. Here it is. Sensor is here. To burn. You can reduce it. You can off it so it will come down on its own. This I will programming I will give you now only soft copy. You can read all the details. Level 0, from there what is the input you have to do, if you use thermocouple you use, if you use these things what is the input you have to do, everything is written. Step by step.
You have sent psychometric chart and everything you have sent to your right, but didn't receive it.
That
Did
you
not
have
get
transferred.
did not get.
What is this SVM?
SV is set value. When you want to maintain certain level, you have to set that level. That is the PV means process value. What is the processing value? Presently, what is the value that it will read? Is the present value or process? Normally, present value nobody will read. It is a layman term. You are using an industry, that's why you call it as a process value.
For thermistor, we have to set these all values.
No, only permission 10 volt you have to set input 0.4 and 1.35. These three because it is calibrated for that particular value. Other things are 420 standard. You can read directly. Only for the thermistor. K type no need to set. Only you set it as a K type in the program. When you go to the level, I'll tell you when you go to the level, here it is there, no? Or is it okay? Level, then input you have to select. Level 0. Input you have to select. In the input you can change it as a, for when you are using K type, you say it as a K type. PT100 is there, Y is there, G, L is there. K only you have to mention. K. That identification in that manual is like that only.
For thermistor, we have to use 10 watts.
10U it will come. I will show you the thermistor also. What this is for that?
For PT100, P100.
PT100 is P100 is there.
Only input is enough for K type, sir?
Yeah, input you have to give K type, resolution, all those things